Okay, so we graphed in 4.3 standard form. Today we are graphing in vertex form. So this should say vertex. Okay, so we are graphing in vertex form today. And vertex form is kind of nice because it already gives us the vertex. That's why it's called vertex form. So any parabola that is given to us in vertex form looks like y equals, and there's going to be a coefficient outside, which is our a, x minus h, so x is still going to be there, but there's going to be a number in there for h. All of that's going to be squared, plus another number k that they give us, and I'll show you guys an example. So where can we find the vertex in here? The vertex is just h comma k, so you ignore that negative sign. Our vertex is h, k. Alright, so we don't actually have to do any solving for the vertex in vertex form. It's already given to us. Because our vertex form has a minus though, what would you think would happen if this said x plus h? What would our vertex be? It would be negative, right? So we do have to make sure that we're careful of that, because vertex form has x minus h. So if you ever get x plus h, your h is going to be negative. Okay? Line of symmetry, what?
When it's like that, we don't have to change it.
When it has a minus in between, we don't have to change it. Okay? Our line of symmetry is going to be the same as what it was in standard form. X equals whatever that h term is. So whatever the x coordinate of the vertex is. Okay? And then same thing about the graphs that we already know. If our a is greater than 0, which means if a is positive, we are opening upwards. So we have a minimum value. If a is less than 0, which means it's negative, we're opening downwards. So we have a maximum value. So that doesn't change. Okay, so now we're also going to be looking at the size of our parabola. Remember how on the homework it told us skinny, wide? Okay, so now we're actually going to be looking at the size of the parabola. If a is a fraction, do you think our parabola is going to be skinny or wide? You think it's going to be skinny, right?
No, but
it's actually going to be wide. Okay, so if our a is a fraction, our parabola is going to be wide, because a is actually the slope of the parabola. It tells us about the slope, and a fraction means that the slope is growing slowly. Okay, so if we get a number that is greater than 1 for a, our parabola is actually going to be skinny, because that means that it's growing really, really fast. So our parabola is growing really, really fast, so it's going to be skinny and narrow, more steep. Okay, so we can use that now to sketch our parabolas. So this is really nice for our examples, because now our examples are, these should be ABCs. Gosh, computer. Okay, so now doing our examples is actually going to go a lot faster. So let's identify our LOS. So for part A, identify the LOS. LOS is just x equals h, and what's h in this case?
2.
Well, it says plus 2, so that means our h is actually negative 2. Because the original form has this as a negative sign. So if it's a positive, that means our h is negative. So that's all we have to do for part A. Part B, identify the vertex, is just h comma k. H is negative 2. What's k?
5.
Positive 5. So our vertex is just the point -2, +5. So let's do part B. Sketch the parabola, or C, thank you. Sketch the parabola. Okay, so we know where our vertex is, so let's plot it. It's at -2, +5. 1, 2, 3, 4, 5. And I know that my line of symmetry goes straight through that. Okay. And then let's look at our A term. Our A term is -1/4. So first of all, is it opening upwards or downwards? Good, it's downwards. And it's a fraction. So is it going to be wide or skinny? It's going to be wide. So let's draw a parabola that's wide pointing downwards. Try to make it symmetrical. Okay. And then part D, we want to state if the parabola has a min or a max. So for D, we have a max, and it's at the point. We only look at the y, so it's at 5. So for the max, we only look at that y value of the vertex. And we're done.
So look at K on the side for the max.
So for the max, we will be looking at K. For the line of symmetry, we'll be looking at H.